In this paper, we will be looking at methods to improve risk analysis of large integrated project schedules, programs, and portfolios. The goal of risk analysis is to determine what will happen with project schedules and costs if certain risks occur, and what should be done to minimize threats and maximize opportunities. The problem: schedule and cost risk analysis of large programs and megaprojects can be complex, time-consuming, but most importantly, may not give meaningful results. These programs may comprise a master schedule with multiple interlinked projects. Integrated project schedule may have tens of thousands of activities and may include resources and cost items. Quantitative risk analysis requires assigning discrete risks and uncertainties to different activities, but because the number of activities is so significant, it can cause inaccuracies and omissions. Moreover, different projects within a program may be managed by different teams and organizations. As a result, the methodologies and processes of risk analysis can be inconsistent. Here, we will propose a methodology of risk analysis that can be applied continuously and consistently to megaprojects and large programs. Schedule and cost risk analysis of large programs requires the following components: an integrated project schedule, an integrated resource pool, a risk register that can be shared among different projects within a program. Risks from this risk register will be assigned to different projects and within different projects to specific tasks and resources. A common depository of mitigation and response plans. The same mitigation response plans can be assigned to different projects. Common Enterprise Risk Register is the centerpiece of portfolio risk management. Risks from a risk register can be assigned with different probability impacts to different projects and tasks. Project risk analysis is performed based on this risk assignment. For example, the risk delay due to supplier will be assigned to all tasks where components from this supplier will be required. However, the impact of this risk could be different for different tasks. Similar to financial portfolio, each project or sub-project within a program has a risk profile, which can be measured by a statistical distribution for different parameters. The risk profile of an individual project can be calculated using Monte Carlo simulation and can be done for different risk categories: cost, duration, technical performance, safety, etc. This paper discusses only schedule and cost risk categories, though. The integrated risk profile is calculated based on the relative importance of each category. Risk analysis helps to compare the risk profile of each project to determine what project is riskier and requires more attention. Schedules for risk analysis and schedules for project management and control don't have to be the same, but should be equivalent to each other based on main project parameters: finish times, milestones, duration, cost, resources, etc. The objective of the methodology is to generate a risk profile of each project and the portfolio, simplify the process of defining and assigning risks and uncertainties, calculate the risk profile quickly and on a regular basis based on input from project controls, quickly interpret the results of an analysis, and finally, streamline the process of assessment and management of mitigation and response plans. Three solutions: schedule quality control. In addition to traditional set of diagnostic tests such as DCMA 14-point inspection, Schedule diagnostics for risk analysis include additional steps which will help to determine problems that may affect results of analysis. Most of these tests are related to the quality of precedent networks and checks for activities with constraints, without successors and predecessors. Schedule consolidation, replacing sequential individual activities with large activities and assigning risk to them. Sub-projects with risks and uncertainties. Insert nested sub-projects with risks and uncertainties to the project schedule. Many problems in project and portfolio risk analysis is related to incorrect assignment of risks to activities. In many cases, risks are not assigned to activities which this risk can affect. Event chain diagrams help to visualize risk assignments and improve the quality of risk models. Event chain diagrams present events as arrows on the Gantt charts. Arrows pointing down is a threat. Arrows pointing up is an opportunity. Size and color of arrows represent risk, probability, and impact. Events can form event chains. For example, one event can trigger another event, or events can be correlated with each other. Event chains are shown as lines on an event chain diagrams and may include arrows to represent triggers and correlation coefficients. Schedule consolidation is used to simplify the project schedule. Consolidated project schedule is equivalent to or has conformity with the original project schedule based on the main project parameters, finish times, milestones, duration, costs, and resources, etc. Schedule consolidation significantly reduces the number of tasks by removing sequential activities and replacing them with large consolidated activities. Risks and uncertainties are applied to consolidated activities, which simplifies interpreting the results of analysis. Most real-life project schedules can be consolidated by at least 20% due to the significant number of small repeated tasks. A consolidated schedule can be used for risk analysis, while the original schedule can be used for project planning and controls. Another way to simplify risk analysis of complex projects is using sub-projects with risk uncertainties. The mathematical foundation for such an analysis was developed as an extension of finite elemental structural analysis and called static condensation. Most structures such as bridges, buildings, as well as other engineering objects such as launch vehicles consist of similar elements. Structural analysis of each element is performed individually. Then such elements are then inserted into the main structure's finite element model. As a result, much smaller models is required to be analyzed. Project schedules also consist of many similar elements and sub-projects. Monte Carlo simulations for each project can be formed separately. Then each sub-project can be inserted to the master project as a separate task with their uncertainties. In a large program or portfolio, Monte Carlo analysis of individual project schedules can be formed individually to generate a risk profile. These profiles are a custom distribution of cost or schedule that can be inserted into a master schedules as one task or a small group of tasks. Risk analysis of master schedules is run based on the risk profiles of these sub-projects. In this project, we perform Monte Carlo for 5 tasks, but 3 tasks are actually sub-projects, which have many tasks by themselves, but they are calculated separately. Sub-projects with risk and uncertainties can be used for risk mitigation and response planning. Each mitigation and response plan is a project schedule as part of a project portfolio. Such schedules also have risks and uncertainties and may in theory have their own mitigations and response. Mitigation schedules are referenced in the risk register. response schedules are inserted to the master schedule automatically if a risk occurs. As a result, schedule changes dynamically on each iteration of Monte Carlo. Conclusions. Managing risks and uncertainties in an integrated project portfolio is a complex process. As a result, risk analysis of complex programs or project portfolios is not implemented or not consistently implemented. The proposed methodology makes risk analysis much simpler and faster, and it can be performed on each phase of the program. The quality of risk analysis can be improved because analysis is performed on consolidated project schedules, which are checked against potential logical errors. One way to improve the quality of risk analysis is to use event chain diagrams. Risk analysis of individual schedules can be done separately but can share a common risk register. This not only simplifies the analysis of the master project schedule, but also allows for a consistent analysis of individual schedules asynchronously. It means that different departments and different managers can perform analysis of their own project schedule, but it will then be reflected in a master schedule automatically. The approach also supports security requirements as it allows for the firewalling of different organizational units who may not need to access schedules of other units. The methodology simplifies the interpretation of results of risk analysis and reporting, and the methodology improves the management of mitigation and response plans.